Good morning. This is Victoria Beal with the Ohio LTAP Center, and we're very pleased to have you on the webinar this morning. This is Day 2, Session 3 of the 2020 National Hydraulics Engineering Conference. And for those who haven't yet joined us for a session, we would like for you to please look for the question box in your GoToWebinar panel and drop us a hi or hello in there. For those of you who have already participated, you don't need to do that. Just remember where the question box is located, because we want to make certain that you're able to ask questions throughout the presentation this morning. So the other thing I wanted to mention is that we do have some handouts for you in the handout section of the GoToWebinar panel, and I'll be adding another one in there a little bit later this morning that will go along with the second portion of the presentation. So I believe that is all I have for right now. I'm going to go ahead and get things turned over to your moderator for this session, Wesley Peck. Thank you. Wesley, if you're talking to us, you're still muted.
I remembered to hit the video button, but not the audio button. All right, sorry. Okay. Good morning, everyone. Welcome to Session 3 of the 2020 National Hydraulic Engineering Conference. My name is Wesley Peck, and I am the State Hydraulic Engineer for Tennessee DOT. And I'm going to be the moderator for today's session. The session title is Methods for Delineating and Evaluating Floodways in 2D Models. And we only have one presentation today. We have two presenters. Mr. Scott Hogan has spent more than 30 years working in the field of river engineering hydraulics. For the past 15 of those years, he's been with the Federal Highway Administration. Scott received his BS and MS in civil engineering from Colorado State University, and he specializes in bridge hydraulic modeling and design, scour analysis, sediment transport, and countermeasure design. And for more than 25 years, he has been an instructor for several hydraulics training courses through the National Highway Institute. Now, our second speaker today will be Mr. Casey Kramer. He is a recognized expert in the fields of hydrology, hydraulics, scour, river engineering, sediment transport, and fish passage. And he specializes in hydraulic design of transportation facilities. Casey is a hydraulic engineer for Washington State DOT, and he currently works for Natural Waters. And he has been involved with over 400 water and transportation projects, and he has a thorough understanding of project delivery within a Department of Transportation. Skate, there I am. They have both asked that we can do questions during the presentation if there aren't very many. So go ahead and send in your questions in the question box as they come to you, and we'll stop a few times during the presentations, and if there are a lot of questions, we will wait till the end. And we will make sure we get done by 12:30 Eastern time, since everyone's time is valuable here. So with that, I'm going to turn it over to Scott, and I'm going to go away.
All right, thanks, Wes, and hello, everyone. Certainly thank you for taking the time to participate in this 2D modeling session this morning. In this presentation, I will provide an overview of methods that have been proposed to FEMA for delineating and evaluating floodways in 2D models. And then in the next presentation, Casey will provide a case study demonstrating how that methodology has been used on a no-rise analysis on a project in Washington State. Now, most of you are hopefully aware that Federal Highways has been actively promoting the use of 2D hydraulic modeling for bridge hydraulics and scour analyses for the past several years. If you're not aware of that, you've probably been hiding. We've had a lot of effort put forth with the Everyday Counts program, and that's been very successful. But not all of you may be familiar with some of the background that led up to these developments and how we got to where we are today. So let me start with a little background here. First of all, Federal Highway Administration, or FHWA, started using 2D modeling way back as far as 1988, as far as I can find. And so we've long recognized the benefits of using 2D hydraulic modeling for detailed bridge hydraulics. Back then, it took a tremendous amount of effort to put together and run a 2D model. So it was not widely used. But a lot has changed since 1988. And since 2012, in fact, Federal Highway Administration has officially recommended the use of 2D modeling for bridge hydraulic analysis in our reference documents. Most of you are probably familiar with HEC 18 and HDS 7. So 2D modeling is not new as far as our push and recommendation of its use. So that goes back to 2012. But since then, we recognize the need for improvements in making the model development and the model results review a lot easier for users. So in 2013, we entered in a partnership with the U.S. Bureau of Reclamation in the ongoing development of the SRH-2D model for transportation hydraulics. And we also initiated a custom graphical interface development in the SMS software package by Aquaveo. Now, the use of two-dimensional modeling has grown significantly, but there certainly are still some barriers to the use of 2D modeling, and FEMA floodplain and floodway analyses are certainly one of them. Although FEMA has approved the use of 2D models for a number of years, the application for floodways and no-rise analyses has been not clearly defined. And as a result, on many projects, although 2D modeling has been used for design purposes, a 1D model has still been necessary for FEMA submittals. And so Federal Highways is most interested in helping to eliminate the need for this duplicate effort. And we've been actively supporting further development and the use of 2D modeling for FEMA analyses. And so starting in 2018, we participated in a Colorado floodway work group, which was a consortium of different agencies, including FEMA and their consultants. And with this group, we proposed delineating floodways in 2D models. We proposed different methods and also methodology for assessing the surcharge or the rise in water surface elevation. And our efforts were well received. And as a result, FEMA formed an interagency project team about a year ago, a little longer, mainly to assess what standards and guidelines need to be modified to best accommodate 2D modeling. And a lot has happened. Or I should say that team has been very successful. Pretty impressed with the engagement and the level of effort there by FEMA and others. So new standards and guidelines have been developed, and they were available, I should say, for public review in July and August, just recently here. And there's still ongoing discussions amongst the IPT group, but I understand that FEMA plans to publish updated standards and guidelines in the November timeframe. So stay tuned. All right. So here's a quick overview of my presentation. I'll cover modeling assumptions and the limitations of 1D modeling for floodway analysis, and then I'll present a new methodology we propose for evaluating surcharge, and then we'll take a brief look at the results of modeling a 1D floodway and a 2D model, and then I'll introduce two methods for delineating floodways within the 2D model. But before I proceed, I would like to bring up a poll question. Victoria, if you could help me out here. I'd like to get an idea of the level of experience in the audience today with analyzing floodways. So I'll pause here just a minute. Okay.
I'm launching the poll question.
Okay, great.
And there's apparently one person who's having some audio issues. I would recommend to that individual to please exit out of the GoToWebinar software and come completely back in, and hopefully that'll get you reconnected. So the poll is up, and people are voting fast and furious. So if anyone's having an issue voting on that poll, please hit the escape key on your keyboard. It should take the screen out of full screen mode, and then you'll be able to vote.
And actually, Victoria, how do I see the results of the poll?
I'm going to read them off to you.
Oh, okay.
Yep.
All right, gotcha. I was just wondering if I missed the screen.
No, you're good. We are up over 80% voted out of the 356, 57 people we have on here. So you tell me when you'd like for me to close the poll down.
All right, that's probably good enough. Let's just see what we've got.
Okay, we're up to 88%, so that was even better. I'm going to share the results. And the top vote getter was 47%. It performed 1D model floodway delineation. And then we have 24% with no experience on floodway analyses. 17% performed mixed 1D, 2D modeling with 1D floodway delineation. And 12% performed 2D modeling with 2D floodway delineation.
Okay,
I'll
great.
hide the results, and
All right,
it's all yours again.
Thanks, Victoria. It's more or less what I expected, but so a lot of you obviously have some experience in delineating floodways. So I do expect this presentation may generate a lot of questions. So I will ask that you enter those questions in the Q&A box, and Wesley will watch those, and I'll check back with Wes occasionally. All right, so let's move on here. So many of us, or most of us, have probably been doing 1D modeling for so long that we tend to forget how many significant simplifying assumptions that we make in 1D modeling. And more importantly for this discussion, how these assumptions can affect the delineation of a floodway. To achieve the desired or expected surcharge in a floodway in a 1D model, these assumptions listed in this table need to provide a reasonable representation of the actual flow conditions. The further that these assumptions deviate from the actual conditions, the less accurate, or let's just say the less reliable, that floodway delineation will be. But the key point of this table is really just to highlight how the need for so many simplifying assumptions, and I'd even say unknowns, is alleviated as we move into the use of 2D modeling. Right? And so in the following slides, I'll highlight a few of these that probably have the most impact on floodway delineation within a 1D model. But before I do that, I'd like to give you a quick overview of the project area that I'll be using for this case study example. The project is located on the Elkhorn River in eastern Nebraska. And many thanks to the Nebraska Department of Transportation and their consultants, Felsberg, Holt, Nolvig, for sharing their project data with me. So for this reach, the 100-year flow is about 86,000 CFS. The modeled reach for the 2D model is about 9 miles long, and the floodplain ranges between 1.5 miles to 3 miles wide. And this modeling effort was completed to support the design of roadway and bridge improvements along US Highway 30 that you can see at the bottom of the screen in the red dashed line. Now this here is a 2D mesh developed within the SMS software package for SRH2D. And in some areas, you'll notice that the mesh is much more refined than others. These areas are more highly refined to reflect or highlight potential hydraulic controls. Okay. For this model, these areas were generated automatically with a new feature in SMS, version 13.1 beta, that automatically delineates ridge and valley features. Okay. This is a significant advancement in mesh development by Aquaveo, and there will be continued advancements with the ultimate goal of having an option to completely automate mesh generation that accurately represents the terrain and also is efficient, that runs quickly. So we're working aggressively to try to minimize the level of effort in this part of model development. And in fact, Alan Zundel will be giving a presentation later this afternoon on some of these new features in session 4. Okay, so getting back to this mesh has 87,000 elements, all right, ranging in size from about 3 feet near the piers at the bridge up to 200 feet in the more open, wide, flat areas. Okay. The model was calibrated to a recent high flood event and measured high watermark data. And since I often get questions on how long it takes an SRH2D model to run, for this simulation to reach a steady state condition, it was a 20-hour simulation, and that simulation took 12 minutes to run, or 12 minutes of CPU time. So there you go. All right, so before we get into 2D floodway analysis, it's important to understand some of the limitations that I noted for 1D modeling and as it applies to floodway delineation. So first of all, this image shows the results of an SRH 2D model, 100-year floodplain limits, with velocity vectors and water surface elevations shown at 2-foot contour intervals. You might note that the highway is overtopped over most of the floodplain width, right? Pretty significant flooding. So since a 1D model assumes that flow is in one direction, okay, just that assumption alone, when we delineate a floodway, oftentimes when we block off lateral flow, okay, that impact is not considered in a 1D model, okay, since we're assuming flow is in one direction. Okay? And as a result of that, we've learned, as you start to model floodways in a 2D model, you'll see many more localized rises that were not represented again in the 1D model results. Okay. Also, a 1D model assumes that flow is perpendicular to each cross section, and that along that cross section, the water surface elevation is constant. Okay. And depending on the actual flow conditions and compared to how the cross section is drawn, this certainly can introduce errors in the floodway delineation. Let me show you some examples here. So I've added these black lines from the current effective 1D HEC-RAS model. You'll note that I did extend the 2D model both upstream and downstream to avoid any potential boundary condition effects. And this cross section here highlights just a typical cross section upstream of the bridge. And I've got a plot here. In this plot, the blue line, solid blue line, represents the 2D model result, whereas the dashed red line represents the 1D result. And you can see across this wide floodplain, there's a difference of about 2 feet, primarily at the left side. And so you can imagine in a 1D model, so the way in a 1D model, we delineate floodways by removing equal conveyance from either bank line. Okay? And so if you think about that, if we're not accurately representing the water surface elevation across that entire section, you can see how that equal conveyance reduction is not truly reflective of the actual conditions. Now, you may think that, well, at this cross section, 2 feet across, 1.5 miles to 3 miles is not that much. But as we look at other cross sections, it becomes even more pronounced. So let's take a look here at the upstream face of the bridge. Now, for those, most of you have been modeling bridges, you know that it's a common practice to draw a cross section along the upstream toe of the roadway embankment and the downstream toe of the roadway embankment, even though it might violate the rule of being perpendicular to the flow. It's just something we've done, and maybe not recognizing how much error we might be introducing. So if we look at a cross section at this location, you can see mainly because of not drawing that cross section perpendicular to the flow, you can see we're misrepresenting the water surface by, essentially there's an 8-foot difference from one side of the floodway to the other, floodplain to the other, that's not represented by the 1D result. And again, you can imagine these differences, in a 1D model when removing equal conveyance, it's certainly not going to be representing a true equal conveyance reduction based on the actual flow conditions. So again, my point here is that just simply how we're drawing cross sections with these assumptions can significantly impact the floodway results. All right. Oops. Okay, so let's move on. And I'm sure most of you are more eager to hear about what we proposed to FEMA for evaluating surcharges. And so the question is, what are we proposing? How do we evaluate surcharge in 2D models? And is there a better way? So ultimately, as we move forward with 2D models, we'll no longer need this reference to cross sections. Okay? And so we have to be thinking about what other reference lines we can use if we no longer need to place cross sections. And so the consortium group that I mentioned earlier came up with the idea of using base flood elevation contour lines as evaluation lines. Okay? and then using averaged values along the lines. Okay. So this averaging approach is consistent with the current state of the practice that we use in 1D modeling. Okay. The BFE contours, the base flood elevation contours, sorry, are already perpendicular to the flow, and their location is not subjective. So they seem to provide a good reference. Okay. And in this example, I happen to be using 2-foot contour intervals, but for future application, I certainly would refer you to the guidance that will be released by FEMA in November on the appropriate spacing. Now, in the bullets on the right, I've outlined the process in the SMS software package for converting these base flood elevation lines to evaluation lines. Okay, so it involves exporting these linear contours to a shapefile. And once you've exported these to a shapefile, it's a quick, you turn around and import those into back into SMS, and you can set them as a cross-section coverage. All right, and once we have the cross-section coverage, at each of those cross-section coverages, we can compute minimum, maximum, and average values. Okay, and it's those average values that we're proposing to use to evaluate changes in the floodplain versus floodway or a project condition. Okay, and also I might note in SMS with those cross sections you have a summary table. Okay, and so it's easy to summarize those results. All right, so in the following slides, I will demonstrate how these evaluation lines can be applied for floodway surcharge assessment, and then we'll talk a little bit about no rise. But first, let me check in with Wes. This might be a good time for any questions that may have popped up.
Okay, we have a question, Scott. Until the new standards come out in November, do you know of any specific resources and guidelines to recommend for no-rise and FEMA-related reviews for 2D modeling in approximate and detailed study areas?
As far as between now and the interim, until it's official guidance, no, I mean, there's nothing official out there. And as you'll see from Casey's presentation here soon, there certainly have been some states and communities that have been moving forward with forms of this methodology. So I guess, Wes, the best answer to that question is coordinate directly with your floodplain administrator, because really that's the most important point of contact. And that's, you know, even when this official guidance does come out through FEMA, it's still going to be up to you know, guidance or the direction of the local floodplain administrator. So as Casey will show in a few minutes, now he's got a project in Washington State where they used 2D modeling for a no-rise analysis, even though the official guidelines aren't out yet. And I know folks in Colorado have been doing the same for evaluating floodway surcharge. So if you missed the public review for the documents from FEMA, I'd say then it's best just to wait until November. If you have other questions, please feel free to contact me, and I can help you with that as well. Anything else, Wes?
Yeah, a couple more came in just as you were talking about that one. What is the timeline for the release of SMS 13.1?
Well, so the beta is out right now, and I guess I could defer to Alan Zundel this afternoon, but the goal is to, you know, it's in beta, obviously trying to work out any bugs, and as soon as it's big issues are worked out, they'll go to a full release, and I would expect that, you know, pretty soon. I'm going to guess within a month, and so that's. But even within 13.1, there's a number of tutorials that aren't available yet that I'll talk about later in my presentation as well. So it's coming soon. I'd say, you know, roughly that month time frame for 13.1 official release.
Okay, do you want any more right now? Let's see.
Sure, if you got another one pertaining maybe to evaluation lines, or if there's anything else general, we can keep that to the end.
All right. It looks like, so you say we need to define a center line, but wouldn't we still need to use the thalweg of the stream or river?
That's a good question. You know, I would say a center line along the river would make the most sense. That line is mainly just used for stationing purposes. So it quite honestly could just be a straight line through the floodplain. But most often we will define the center line down the Thalweg. Great question.
Okay. Typically, a peak flow is used for 1D delineation, which gives the conservative sense to the analysis. How does switching to unsteady state impact the conservativeness of the floodplain delineation?
Well, it certainly switching to the unsteady, if that's what the community or state is going to require, does change the delineation. And that's something that is still being discussed amongst the FEMA IPT, that project team. There have been there's been a lot of trials with that. At this point, we've been focused primarily on peak flow analyses, but this methodology can also be checked or used to some degree with the unsteady flows. Quite honestly, I mean, that's an area where we're still looking at, are there barriers or there issues we run into with unsteady flow? So.
Okay, looks like you've covered all the ones specific so far. There's a couple of general questions that can wait until the end.
Yeah, okay. Why don't I go ahead and let's look at the impacts of evaluating the current effective 1D floodway, okay, so modeled in a 2D model. Okay, so that's what we've got here from the flood hazard map, just simply taking that current effective floodway boundary and incorporate it into the SMS software package. And the way that's done is you basically take your materials coverage, add in the floodway boundary, and you can turn off or change the material type of all of the area outside of that boundary to unassigned, and essentially just treats it as turned off when you run the simulation. So it's pretty easy to run a floodway scenario just simply by setting this floodway boundary with the material coverage and rerunning that and comparing it to the result to the original base flow. And in SMS, there are tools, the data calculator specifically, where we can take that floodway simulation and subtract the water surface elevations from the base flood simulation to directly assess what the surcharges are. And so this plot shows the surcharge color contour plot showing the surcharge for that 1D floodway, again modeled in 2D model. If the red areas denote areas that exceed the allowable 1 foot surcharge, and there's different shades of green for the values under a foot. Now, if you happen to be colorblind or can't see red and green too well, I've also added point values. And I might note that towards the upstream end, there's even areas where the surcharge exceeds nearly 3 feet, okay, or exceeds, it's almost 3 feet. So that's significantly higher than that allowable 1 foot surcharge. Now, this is not true for all 1D floodways modeled in a 2D model, but I can say without exception that any 1D floodway modeled in 2D will result in higher surcharges than are predicted with the 1D model. And so that's mainly because all the assumptions I talked about earlier, but it's something that I've seen in most projects, and but some of them again are quite high. My hope in all this is that you're seeing how important it is to move into 2D modeling to delineate floodways, and mainly because of the number of assumptions. All right, so let's take a look at these evaluation lines and how we would apply them for evaluating this 1D floodway. Okay, so you can see the evaluation lines shown here, and if we averaged the water surface along that evaluation line within the floodway limit, okay, and then we show the results over here in the table, you can see the average rise as compared to that the base flood elevations. And so the rows highlighted in red obviously indicate that where they exceed the allowable 1 foot surcharge. Okay, so that's pretty straightforward. Now let's take a look at, let's go ahead and move into the methods that we proposed for delineating 2D floodways. First of all, there's the unit discharge reduction method, and then there's also the unit discharge method. The equal discharge reduction method is most consistent with the current 1D modeling conveyance approach, the equal conveyance reduction approach. This is where flow area is removed from either edge of the floodplain until the target rise is achieved, okay, but not exceeded. Okay. This approach still requires the use of cross sections for evaluation, and you'll see in the right so those blue lines, but the alignment of those cross sections is really not important or not critical. All right, they're simply reference points. And the alignment is not critical because in the 2D model, at each element, it can evaluate the flow direction and correct for that accordingly. Okay. So floodway tools have been added within the SMS SRH2D interface to automate the process, but there still are a few steps required by the user. Okay, so to start with, we still need a channel center line for stationing, and then also we need to establish bank lines. Okay. The main reason for the bank lines is to limit any potential encroachment on that floodway across the channel. And that could happen in areas where you've got really large meander bends and have a lot of flow on one side of the floodplain. And so to prevent any kind of encroachment across the channel, that's what we use the bank lines for. And for that matter, the bank lines could be used to wrap around any other areas where you don't want the floodway to encroach. Okay. And then to get to this floodway tool, I simply right-click on this center line coverage and you'll see a floodway option. This has actually been in SMS since version 13.0, but probably most would not know that. And after that, you select the encroachment method, right, and the appropriate geometry and solution from the base flood. You set the desired or the maximum rise. And then this last box, the number of divisions, that's just a number of additional cross sections that are interpolated for computational purposes. For right now, that's set at 200, but we might change that as we learn more about the tool. And again, this is all automated. Once you click OK, currently SMS automatically delineates that floodway, creates the materials coverage, and it's all ready to run an encroachment simulation. And then once you do that, you can compare the results with the base flood and see what it looks like. And so for the equal reduction method, this is the same differential contour plot showing the surcharge with a target rise of 1 foot. All right, so now if you've done floodway analyses in 1D modeling, you know that when you set the target of 1 foot, you don't automatically get a 1 foot rise everywhere. Okay, and so the same thing holds true in this method. It's a target, all right? So it goes through each cross section, makes some approximations, and delineates that floodway. You run it and check the result. And in this case, if you look off to the right, based on the assessment at the evaluation lines, you can see the resulting surcharges in the right column. And in fact, there's only a few that are even approaching a foot. And so this, you could even increase your rise and possibly squeeze these up a little higher. Right? I did not do that for this example. But you can see we've got rises upwards of 0.8 of a foot. It's not too far away. In addition, the user or modeler can also manually modify the floodway boundary in certain areas, for various reasons, and then rerun the simulation and check those results. You also might note in the third row down, you'll see a negative surcharge. Okay, those have not been allowed with a 1D model, but they will be allowed to some degree with the 2D model. So certainly take a look at the FEMA guidance on that. Oh, actually, I missed one thing there. So in addition to these evaluation lines, there will be additional criteria from FEMA regarding any point rises that might occur between the evaluation lines. And to my understanding, that there will be a tolerance of a ½ foot. So in other words, there at any point, the rise could be a ½ foot greater than the allowable surcharge. But certainly stay tuned and look to the official guidance for that. In this case, the red areas, those values are above a foot, but after further review, all of those are less than a 1.5 foot, okay? So this result would be acceptable both on the averaged values at evaluation lines as well as point values. All right, so now let's look at the unit discharge.
We just had several new questions come in if you want to take a shot.
You know what, Wes? I have got like a couple slides left, so let's finish out and then let's take them all at once. Okay.
Okay.
Yeah, thanks. All right, so this method of unit discharge, it's based on simply depth times velocity. All right, so you can take the solution from the 2D model and multiply depth times velocity and get that unit discharge. And we use this then to delineate basically a risk-based corridor. Okay, so it's very important to understand that this unit discharge method really has nothing to do with floodway rise. Okay, it's simply a method. It's a risk-based method to define a corridor that could then potentially be used as a floodway boundary. So it's important to note that a specific unit discharge does not correspond to a specific rise. It will be different for each reach and for each river, especially if you're targeting a certain surcharge. I know that in some states and communities, they are interested in managing a risk-based corridor, so they may select a unit discharge of say 3 to 5 CFS per foot, use that as their floodway boundary, but then they just have to verify that the rise associated with that boundary does not exceed FEMA's allowable limits. Okay. Now you'll see in this image on the right, which is a color contour plot of unit discharge, it's kind of messy. And if you were to, like in this case, the example is 5 CFS per foot. If I were to delineate every location that met that criteria, there would be actually a lot of islands if you see in the middle. So for this procedure or methodology, we ignore all of those islands. They're excluded. And we only use that outer boundary to represent the floodway corridor for the unit discharge method. Now, same thing, it's very similar to the unit discharge method as far as approach in SMS. The user, it doesn't require a center line. Oops, I'm sorry about that, lost it. It doesn't require a center line, and this one actually does not require channel bounds either. You select the discharge method, the appropriate solution, the desired threshold of unit discharge, and click OK, and it automatically generates the materials coverage, so you can run the simulation and compare the results. Here's the results again, very similar approach. You see a color contour plot, a few red areas that exceed a foot, but as with the unit discharge method, none of those average surcharges exceed the allowable rise. Okay. Now on this last slide, I've got just the outer delineation of the floodplain limits for comparison purposes. And I might note that both the equal discharge reduction method as well as the unit discharge method could have been further iterated to get a slightly narrower floodway. There's certainly some optimization, but I can say with certainty that any 2D floodway will be wider than the 1D floodway, okay, for the reasons we talked about earlier. And then another thing before I close and open up for questions, I want to emphasize that all of these tools that I've mentioned here are either already included in the free version of SMS or in 13.1, and even more will be added to the freer community version as we progress and the full release of 13.1 comes out. So I always get a lot of questions on that. You have to understand this is all free to the public. Definitely contact with me with any questions on that. And then just this last slide, If you are interested in additional resources and staying up to date on the latest 2D modeling tool development, floodway developments, and best practices, please just send me an email and I'll respond with a bunch of links. You're welcome then to sign up for our bi-monthly webinar. And I'll just end with that. I appreciate your time and wish you the best in your modeling endeavors. So what other questions do we have, Wes?
Okay, I'm going to give you a few of them, but then we'll quit after a few minutes so Casey has time, and anything that's left we'll put at the end of Casey's presentation.
Sounds good.
Question: would it be better to use a straight line along the approximating the BFE contour as a better evaluation section?
So would it be better to use a straight line? I would say no, based on what I talked about earlier, is that straight line, well, one, when we place that straight line, we don't know where that actual water surface elevation is constant. And bottom line, that straight line is not representing where the flow is necessarily perpendicular, or if the water surface is indeed constant along that line. Unless I missed something about that question, you can help me out, Wes.
I don't think so. That's the way I'm understanding it.
I guess going forward, if we were to just place random lines for use as evaluation lines, we could do that. That was discussed, but again, that's very subjective, and you can find people actually placing evaluation lines in strategic locations to avoid showing impacts from their project. One of the benefits of using the BFE contours is that it's much less subjective. Maybe that is a better answer to the question.
Okay, next question was, how do you address negative surcharge in 2D modeling if you encounter them?
Well, so far, I mean, FEMA recognized by changing conveyance and changing flow distribution that you might see a reduction in water surface. The biggest thing they're interested in is that reduction is not caused solely by an increase in velocity. And so for now, they're acknowledging that negative surcharges will be allowable in 2D model floodway analyses. But again, there's some ongoing discussion there and wondering if we need to place some other criteria along with that.
Okay. Isn't the flow direction dependent on the break lines in the topography and the definition of the mesh?
Isn't the well, yes, the flow direction is, I mean, the flow direction is directly computed within the 2D model. And so that's what's nice about using the base flood elevation contour lines, is that at every location, they are perpendicular to the flow because it's delineating that even water surface. Hopefully I got to that one.
Well, if anyone needs further clarification, they can, send in, again, or they can wait until the end and we'll see what happens.
Okay, certainly.
I think we have time for one more before we get to Casey. Do state floodplain managers have access to be able to review projects using SMS?
Absolutely, great question. So, well, first of all, there's more and more features that have been added to the free version of SMS. So that absolutely should not be a barrier. And it's even changing in more and more of the components are being added to the free version. But that being said, if it's of any concern, any reviewers get a free copy of the full pro version. And that's something that Aquaveo has agreed to. So you can certainly contact Aquaveo directly, or since I've got my contact information here, if you have any questions on that, just please contact me and I can hook you up with the right contacts.
All right, I think let's go ahead and let Casey get started. And there are several more questions that we will handle at the end.
Okay,
thanks,
Wes.
Nice job, Scott. So thanks everyone. So let me get my screens organized here. So hello everyone, and thank you for taking time to participate in this 2D floodplain and floodway modeling workshop. Definitely would also like to thank everyone who was involved to make the virtual 2020 NHEC conference happen, and allowing me for this opportunity to present. As Scott mentioned in this presentation, we'll provide an overview of a case study that utilizes some of the methods that Scott just went over. In addition to, like he discussed, some of the information that'll be coming out from FEMA for evaluating floodplains and floodways with 2D models. And as Scott mentioned, please do note that everything actually in this presentation was done, performed prior to those draft guidelines being available for public review. And with that, let's get into it. So first and foremost, this case study really couldn't have happened with many people. Definitely want to acknowledge Washington State Department of Transportation, Julie Heilman in the headquarters hydraulics office, and the region office, the South Central Region office. The survey crew was spectacular, led by Kevin Colacio, and really their forward-thinking effort to be able to utilize 2D models for this analysis and to support project delivery was a great thing to work with. Also, Yakima County Public Services was a huge part in the success of this project. They are the floodplain administrator and ultimately approved this method for meeting a FEMA no-rise. And really, again, without their support and forward-thinking initiative, this definitely wouldn't have been possible. The Bureau of Reclamation also was a huge contributor. They had performed a significant amount of topographic and bathymetric data collection, and we're willing to share all of that. So that combined with the great WashDOT survey crew really allowed for a modeling domain of over 4 miles long and about 2 miles wide. So a lot of data. And finally, the NHC Olympia staff for assisting with this project. So just as a brief overview for the presentation, we'll go over some of the benefits for project delivery, so a brief background, the hydrologic assessment that was performed along with the FEMA no-rise procedure, the 2D model hydraulic development, again, the 2D hydraulic model no-rise assessment, and both of the floodplain and the floodway, and then finally we'll go over some conclusions. And as similar as with Scott, if there is any questions, feel free just to ping Wes and we'll present those. We'll ask those as we're going through the presentation. So after working with several states across the nation, one of the most consistent challenges that we've heard is really dealing with FEMA. And of these challenges, again, one of the inefficiencies and thus the aspects that can really affect project delivery, meaning project schedules and project budget, is this concept of a no-rise or having to submit CLOMARs. And so one of the benefits of being able to utilize 2D models for floodplain assessments and floodway assessments is this whole concept of actually being able to utilize one hydraulic model for all hydraulic assessments that are required for project delivery. And this could be everything included for bridge hydraulic modeling, what we'll be going over today, the floodplain and floodway / no-rise assessment. Also, scour assessments, scour countermeasure design, temporary work platform assessments, both prior to and during construction, fish passage assessments, etc. Those are just some of the few assessments that were actually utilized for this project. But with all that said, this case study really just focuses on a bridge retrofit and a bridge replacement project. It's located on State Route 21, which is shown right here with the red line. And it's located in Washington State on the Yakima River, just north of the city of Mabton, Washington. So this right here is showing the bridge that's being retrofitted is Bridge 241-5. It's on the main channel. And then Bridge 241-2 is located in the floodplain. And this is the one in the floodplain is the one that will be actually being replaced. To put this project site in context, as part of the bridge scour assessment, a pretty thorough analysis on channel migration was assessed. This graphic was developed from available LiDAR, which you can see some of the old channel meander scars. And so with this, the historic channel migration zone was delineated. Also, in addition to the available LiDAR, available aerials were used to assess channel migration. And what this allowed us to do is to assist in determining the risk of the channel movement through the design life of the proposed structure. So the hydrology for the site, we were pretty lucky. The hydrology of the site was developed from a USGS gauge, just shown right here in the photo, that was located just downstream of the main stem bridge. And this gauge actually has just under 50 years of peak flow data that was available for doing a hydrologic assessment. So in addition to a flow frequency analysis that was conducted on that gauge following Bulletin 17C, the effective FEMA flood insurance study was also used in the model development. The FEMA 100-year flow really ended up being utilized for both the no-rise assessment and ended up being utilized for the hydraulics and the scour assessment as well. The flow, that's what is shown here in the bold. The dark bold is actually what was utilized for the hydraulic and the scour assessment. And so for the 500-year flow for the scour check flood, the 69,500 CFS from the stream gauge analysis was utilized. So as you can imagine, the project site is located in a FEMA regulated floodway. This graphic is actually right off of FEMA's National Flood Hazard Layer website, which if it's available and it's updated in your project area, it's actually a pretty handy tool. This is showing the effective floodplain and the effective floodway. And then this red box is the next slide, just zoomed in a little bit to give a little bit more detail. This is showing, again, the same zoomed in view of the previous slide. Shows the base flood elevation shown as the squiggly lines, the FEMA cross sections that were utilized for the original effective 1D model, and also the yellow line, which is the State Route 241. The bridge that in question, the main stem is obviously over the main stem, and then the floodplain bridge is located on the bottom just below the main stem of the bridge. Also noted on this is the downstream boundary condition that ended up being utilized for the modeling effort, and that was that base flood elevation of 661 shown on the right-hand side of the graphic. So with that, Victoria, could you put up the poll question?
Sure will. Let me get it up and running here. Can you hear me okay?
Yep.
Okay. Got the first poll question up. And folks are starting to vote. Once we get a high enough voting percentage, I'll go ahead and close it out, share the responses, and then also read those off to you.
Great. Thank you.
And I want to thank everyone for the great questions that have been coming in via the question box. You guys definitely know where that's located and are not shy about using it. So we appreciate that, because in our virtual world, getting those questions in helps with the interactivity and enhances your learning. So, all right, we're up about 65.
With that said,
voted.
is there any questions that we could take when the poll's being?
Actually, there was a comment that came in that there wasn't any option in the quick poll for those who haven't used 2D modeling. Just wanted to share that.
Oh, great, thank you.
Wes, is there any questions you want to?
While we're waiting here, I have one for Scott here that is probably pretty simple. How do you get the free pro version?
How do you get the free pro version from a reviewer standpoint? Simply just send me an email. That's I can send you the link. Any reviewers simply have to complete the form and send it to Aquaveo. And if that's your role as a reviewer, you can get a free version. Now, again, just to clarify that, all states and federal highways employees, we have arranged licenses for the pro version. So, so if you're a state or federal highway employee, you already have the ability to get that. Just contact me.
Okay, I closed the poll question out while you guys were talking and shared the results because we seem to have topped out on our voting percentage. So we have 70% that selected bridge hydraulic modeling. We have 48% that chose scour assessment, scour countermeasure design, 43% that chose floodplain and floodway assessment, and 16% that chose temporary work platform assessment.
Okay, great.
I'll hide
And
those
actually,
results. And
let's
it's all
take this
yours again.
opportunity too to actually have the other poll question as well. And at that time, Wes, did you say that there was any questions?
There aren't any for you just yet. They're all still leftover ones from Scott.
Okay, great.
I mean, I would say go ahead with yours and we can save these for later.
Okay. Victoria, are we able to put the other poll question up too?
Sure. I thought we were saving it for another slide. Sorry.
Oh, you're good.
Okay, I've got that one up. Have everyone hopefully vote quickly. It's kind of hard sometimes to fill the silence while these polls are running. I like the feature of asking the questions. Maybe if you guys have some questions for Casey, you can put them in the question box real quick and we'll get them read off.
I do have one more simple one for Scott here. Well, if we want to do that while we're waiting.
Yeah.
What sort of computation time was required for the 2 floodway boundary delineation runs?
That was, so the original model was about a 12-minute run time, and so I don't have the numbers exactly, but the floodway runs would be commensurate with that or less. So it certainly wouldn't take any longer.
And the follow-up to that was, would these methods require creating a current effective model?
So that's a good question, and I think Casey's maybe going to get into that a little bit. That's still, I think, where things are a little bit fuzzy in how you transition from a current 1D model, effective model, to a 2D model. In Casey's example that he's showing here, and Casey, you can clarify this, but they didn't have access to the current effective model and were able to jump right into a existing conditions or corrected effective model.
That's correct.
Okay, while you guys were talking again, I closed the poll question out because we looked like we'd maxed out on voting.
Perfect.
We have 37% that chose have not assessed a no rise before. 32% chose no rise using a floodplain and floodway model. 21% no rise using a floodplain model, and 10% no rise using a floodway model. There you
Fantastic. No, that's great. And thank you for that, everyone. So yeah, and I think that reflects, you know, Scott and I and some others have been doing some peer exchanges across the nation. And one thing that has come up is just this inconsistency in the interpretation of the no rise procedure, really depending on what state and local jurisdiction you're working in. And as kind of came out of that poll, some states are only assessing a no rise using the floodplain model. Some states are on assessing a no rise using the floodway model. Some states are utilizing both. And so hopefully this presentation, and in addition to the new updated FEMA guidelines, will provide a little bit more clarity on that, because it is, like Scott mentioned, kind of a fuzzy topic that's been going on for quite some time. I will say with this project, through discussions with the local floodplain administrator and FEMA, and as is presented in this workshop, the no rise was completed with both the floodplain and the floodway models. And with this said, much like Scott was mentioning, is I can't stress enough just early and often coordination and communication with your local floodplain administrator, just to make sure everyone is really on the same page. So for those that voted that they haven't conducted a no rise, I just wanted to go over really quick on the general FEMA no rise process. So the first thing that Scott just alluded to as one of the questions was that the licensed engineer would obtain the effective model from their local floodplain administrator or FEMA. And like Scott mentioned, in this case, no model was actually available. If it was available, then the licensed engineer would duplicate the results of the effective model, and this would then create what's called the duplicate effective model. After that, the engineer would make any corrections to that model to create a corrected effective model. Now, the corrections may include improvements such as technical errors in the effective modeling, or the inclusion of any floodplain changes that occurred prior to the date that the effective model was actually developed. After that, the engineer would develop a model for existing conditions, and this would reflect any modifications that occurred within the floodplain since the date of the effective model, but prior to the proposed conditions or prior to the project. And this is what creates the existing conditions model. I realize there's a lot of terms to throw out here, so I'm trying to make this as smooth as possible. So in this case, since no effective model was available, as Scott mentioned, the corrected effective model is basically equivalent to the existing conditions model. The licensed engineer would then modify that existing conditions model to reflect the proposed development, in this case, the bridge replacement project. And this would then become the proposed conditions model. You would then basically subtract the proposed conditions from the existing conditions, and that's what you'd be utilizing to assess that no-rise. And if you have a no-rise in both the floodplain and the floodway, then a no-rise certificate can be filled out, sent into the local floodplain manager. And I guess that is an important note. When you are doing a no-rise process, one of the benefits is it can be more streamlined in that you're not typically having to work with FEMA. Everything would be through the local floodplain manager. So getting a little bit more detail on the 2D hydraulic floodplain model development, the 2D floodplain model consisted of approximately about a 4-mile reach with a floodplain that varied from about 1,000 feet downstream of SR 241 to about 10,000 feet upstream. Again, just utilizing best practices, the domain was really selected such that the boundary conditions did not affect the model results of the project site. And this is also verified through a sensitivity analysis. On the other hand, the 2D floodway model, it basically had the same procedures as the floodplain model. The only big difference is that it utilized the FEMA floodway boundary to really set the lateral extents of the domain. And Scott mentioned, there is a couple ways to do this depending on what program you're utilizing. You can set it to an unassigned value in your materials coverage within SMS. In this case, we actually just trimmed the domain and basically so there was no elements outside of that floodway boundary. And in this case, in this image, the floodway widths varied from about 800 feet downstream to about 4,800 feet upstream. So almost on the upstream end, almost half of what the floodplain widths were, or more than half of what the floodplain widths were. So again, specific to this project, we had 2 bridges that were in question. Again, the 241-5 bridge was over the main stem and it was only being retrofitted. So therefore, the existing conditions and the proposed conditions are the same. One cool thing you can see in this image is just some of the amazing work of the South Central Region survey crew led by Kevin Colascio. You can actually visualize in the terrain data some of the erosional and depositional features near the bridge. So on the other hand, the existing 241-2 bridge, this is the floodplain bridge. The existing bridge is a 6-span structure consisting of 7 in-water piers, and each of those bents or piers consist of 16-inch or 7 16-inch piles per that bent. The proposed bridge, on the other hand, bridge 241-2, is going to be a 3-span structure. And it's going to utilize, the in-water piers are going to utilize drilled shafts, where above the drilled shafts, they're going to consist of 5-foot columns. So it's going to be, ultimately what it's going to be is a reduction in the number of in-water piers within the 100-year flood. again, and so here's a depiction of what the existing bridge and the proposed bridges and their corresponding meshes and SMS look like. Again, the bridge on the left is the existing conditions with the 7 piers. The bridge on the right is the proposed bridge. And as you can see from this graphic, the project will definitely increase the amount of conveyance that's available to go through the crossing just by removing the number of piers within the wetted water width. Okay, Wes, I'm gonna take a stop there. Is there any questions at all yet?
Well, there is one that came in that's pretty relevant to that slide you just had. It says, how are you handling no-rise crossings that significantly expand the opening due to fish passage, you know, like back to closer to natural conditions, but have an obvious rise downstream due to, you know, historically undersized structure?
That's a great question. Actually, that's one of the, someone must have seen the conclusion slide, because that's one of the points that we are saying is needing much more conversation. So let me hold off on that one, because that could actually probably be a presentation in itself, because it is something that did actually happen in this project and has happened in many other projects where, like the question, the person asked that question is alluding to, by opening up that area, you can actually increase the conveyance through a given structure. And this is particularly true when you have 2 structures, that one or the other can increase the conveyance. So I'm going to pause on that and let's see where we're at with in the conclusions to maybe tackle it again. Is there any other questions?
Yeah, here's another one relevant to that slide you have up right now. Is there any reason for using paving mesh around the piers?
I think really the best practices in this case, one thing that, you know, in this case, the reasoning for the mesh looking the way it does is that this mesh was utilized for a variety of hydraulic assessments, and one of which included not only the existing conditions with the 16-inch piles, but it also included the analysis of the temporary work platform. And so there was other analysis that really drove the size of the elements and whether you use paved or patch. So I think following best practices, it really kind of depends on the water crossing. With that said, I would say that an important takeaway is just to make sure that you, whether you're using patching or paving, just make sure that you have a good number of elements that represent the waterway opening. There's been some misconception with various models on how that is performed. And so I will just use that opportunity to say that make sure that you do have a large number of elements that represent the channel cross section, independent of what model platform you're using. Good questions.
And another one that harkens back a few slides. What is the duplicate effective model required to duplicate? Is that the results of from the effective model?
Can you say that again?
What is the duplicate effective model required to duplicate? Is it supposed to duplicate the results of the effective model?
Yes, and in this case, I believe the FEMA requirements, both existing and in the new, are going to be that you would replicate the water surface elevations at the BFEs and the cross sections within 0.5 feet. And actually, that's a great transition, because that is a point of this project, or the point of this slide. This slide is depicting the corrected effective model, which in this case is the existing conditions because of the effective model not being available. And so as previously noted, the FEMA flood insurance study flow and the base flood elevations, or the base flood elevation on the downstream end shown here, was utilized for the boundary conditions. And with that said, this quote unquote corrected effective / existing conditions model was shown to illustrate that the water surface elevations were, again, they were within that ½ foot of the effective base flood elevations and the cross sections in the effective flood insurance study or flood insurance rate maps. And you know, walking through that no rise procedure, so once that corrected effective / existing conditions model was completed, Alluding back to the process that Scott was mentioning, the contours at specified intervals. So in this case, we're just using 1 foot contours, but you could select any level of precision in what contours you'd want to do. So in this case, again, the 1 foot contours were utilized and they were converted to evaluation lines in SMS. And these evaluation lines are very, very important, as Scott was alluding to, because this then becomes the line that you will compute a discharge weighted water surface elevation to compare the existing conditions to the proposed conditions. So this is a really important part of the process that has been worked through FEMA, and I believe will be part of their new guidelines that they're hopefully putting out, like Scott said, I believe in November. So again, that critical step of utilizing the water surface elevation contours from that existing conditions model, turning those into evaluation lines, and then you would go in and put in your proposed conditions. In this case, again, the main stem bridge didn't change, so we didn't have to update that, but the floodplain bridge in this case was a new bridge, so that new geometry was placed in the model and ran. And so what happens then is, in addition to what would then happen is those evaluation lines that were depicted in the existing conditions model would then be used to assess the discharge weighted water surface elevations in the proposed conditions. And again, this is what that comparison is done. I will say that part of the FEMA criteria that will be coming out, and Scott alluded to, and that we did on this project, is that in addition to the discharge weighted evaluation, we also did a difference plot of the full 2D domain. So in other words, at any given element, we were able to compare the proposed water surface elevation to the existing conditions water surface elevation. And what was important in that is that we were able to note that there was no insurable structures that would be located within any kind of a local rise. So that is another assessment that was performed in addition to the discharge weighted evaluation lines. And finally, once you follow that process of getting the existing conditions model ran, developing the evaluation lines, running the proposed conditions, and then assessing the discharge weighted water surface elevation at the same evaluation lines, you're able to do a difference. And it's this difference that is used to demonstrate whether or not you have a no rise. So in this case, and again, this is just as an example, in this case, the 1 foot water surface elevation contours, 661, which was the downstream boundary, all the way through 664 were evaluated, and ultimately the existing conditions and the proposed conditions met the no rise criteria. So similarly, so that was the floodplain model. Now, similarly, like we talked about before, when you were developing the floodway model, the same kind of procedure went underway with that distinction that instead of having the full lateral limits of the domain, the effective FEMA floodway boundary was utilized to truncate the lateral extents of the model. So again, the same FEMA FIS 100-year 1% flow was utilized, and then also the BFE was utilized as the downstream boundary condition. This was then run for existing conditions, and then similarly to the floodplain model, the project was placed in this and reran, where the water surface elevation, the discharge weighted water surface elevations were then assessed at the same evaluation lines as the existing conditions. Also, though, similarly to the floodplain model, we also looked at point values by doing a difference plot with an SMS of the proposed mesh, or the proposed water surface elevation results minus the existing conditions water surface elevation results to look at any local rises within the floodway.
Hey, Casey.
Yeah.
There are a couple of questions that might benefit from being asked now before you get further away from it.
Sure thing.
One of them is, what is the mesh element sensitivity if the mesh upstream and downstream of the crossing are adjacent along with the structure.
What was the mesh sensitivity?
Uh-huh.
That's a good point. So that I would put that into more or less best practices. So I was mentioning the sensitivity analysis on the locations of the domain. Other sensitivity analyses that anyone should run, irregardless of the type of 2D model being ran, would be mesh sensitivity, Manning's N sensitivity. Yes, variety of sensitivity analyses that should be undertaken to see how the model development would change if you were to change that given attribute. So in this case, to answer that question specifically for the mesh, there was a sensitivity analysis conducted on mesh size to make sure that there was no change in hydraulic model results. Did that answer that question, Wes?
I think so.
Okay. Whoever answered the question, please follow up if you have additional questions or if I didn't answer it correctly or fully.
One additional one that says, what line is used for velocity results? This came in about 2 slides back.
Oh, what line is used for velocity results? So I guess my answer to that would be it really depends on what you're utilizing those velocity results for. And that almost is a separate presentation probably in itself, because if you're utilizing, for example, if you're utilizing velocity results for doing contraction scour, you may want to use a similar type of discharge weighted value or cross-sectional average value in the use of some of the scour computations. Whereas if you're computing local scour at a pier, you actually may want to utilize the local velocities that occur around the pier. And I will kind of point to that there is some great tutorials that Federal Highways and Aquaveo have put together that kind of explain that. But please do follow up with Scott or I if there is further questions on where to extract 2D model results to use in various analyses.
Okay, one last one real quick that's came in from several people is a no rise to the 100th of a foot. What exactly is no rise? I can answer that one for you. In Tennessee, it's 0.00 feet according to FEMA.
Yeah, and that's where I would say, based on some experience, it varies where you're at, and that's where I would the early and the often coordination / communication with your local floodplain administrator and or FEMA, depending if you're doing a no rise or a CLOMAR LOMAR, is critical, and that's where I would probably start that conversation.
Okay, we'll save the rest for a little bit later if you want to go ahead and continue.
Okay, thanks, Wes. Yeah, no, great questions. Trying to remember, I went back up to a slide. I think this is where we left off. So again, similarly to the similar to the floodplain model, you would do the same assessment of the proposed conditions and the existing conditions with the floodway model. So again, in this case, you can see again, only in this case, utilizing the 1-foot contours as those evaluation lines, we were able to demonstrate that the proposed project was able to demonstrate a no rise based on that bridge replacement. And that caveat again out there that utilize the benefits of all the 2D model results, and some of the features in SMS. Again, there was that difference plot that was created that subtracted the proposed water surface elevations from the existing conditions water surface to look at local rises, and ultimately assured that there was no insurable structures within any kind of a rise. Okay. Well, with that, in conclusion, I hope what everyone takes away from this, if there's anything, hopefully there's a little bit more clarity on a no-rise assessment. Point everyone to the new methods, procedures that are being provided by Federal Highways and FEMA But ultimately, you know, one great thing that should be an eye opener to a lot of DOTs, because it's gonna save money, it's gonna affect project delivery in a positive way, is that use of one hydraulic model. I mean, so many times, you know, with the invention of 2D modeling, we would be utilizing better information for doing scour assessments and other assessments to support project delivery. But then everyone would say, oh, we got to go and submit something to FEMA. And so then there would be this need to create an additional 1D model that would kind of quote unquote dumb down the results and be an additional cost and potential schedule impact to project delivery to get through. And so that's where this new concept by FEMA is actually great, being able to utilize one model consistently across all the project delivery elements, whether it's you're doing your bridge hydraulics, your floodplain, floodway assessment, scour assessment, scour countermeasure design, etc. Again, and in conclusion, a no-rise for this project was successfully completed, and following that similar protocol to the upcoming FEMA new standards and guidelines for assessing floodplains and floodways. Again, please note, this was performed prior to that being out for public review. And so there is maybe a little minor modifications that might need to be taken to follow the FEMA protocol, but it's pretty much in line with those. Again, based on questions that I'm hearing from folks and some of the poll questions, I really think additional communication and clarification is needed to more consistently implement FEMA standards. As noted before, and again, as came out in those poll questions, one of the more consistent challenges we've heard in collaborating with state DOTs is dealing with FEMA. And I think having clear direction at the scoping level of project delivery and being able to utilize one hydraulic model for all analyses can really save DOTs a lot of time and money. And to someone else's point earlier, question, there is some other challenges that this presentation definitely didn't delve into, which was noted is such as flow distribution changes due to bridge replacements. And I think this really needs further discussion. And again, there's not enough time to cover all these aspects related to 2D models, but ultimately, I think the greatest hope is that this workshop presentation, in addition to Scott's, will really spark some questions and lead to some additional conversations to ultimately improve the state of the practice. So I think that's where I think we'll end. And no, thanks for the opportunity. I guess Wes and I don't know if Scott can join. Maybe we can tackle Scott's questions, and if there's any remaining questions on this presentation.
Okay, one just came up for yours, Casey. How long did this process take?
The processes of the no-rise, it was all within here. So here's something that could be, yeah, that's a great question. This process was not outlined in the scoping level of the project. And so this process was done within the original timeline of the project. And so it did not delay the project. And I got to say, that's all due to WSDOT and Yakima County. I mean, they both were forward thinking and very great to work with, and so yeah, as far as the timeline concern on this project, as an example, it all fit within the existing the schedule of the project and didn't delay project delivery.
And this one's more of an observation than a question, but given some of the information that Scott showed in his presentation, it seems like meeting the 0.5 maximum increase between the effective and duplicate effective in it, when moving from 1D to 2D is going to be very difficult in many situations. I think that would be my experience with it for sure.
Yeah, Wes, I can comment on that. No doubt there's some things to be learned here as we move forward. To be honest, it took a lot of effort to get to this point, and working with FEMA to get new standards and guidelines updates. there's no doubt that this is going to be a work in progress. And even when they come out in November, it's going to take time to implement. I mean, I know FEMA's been talking about training to provide to floodplain administrators, and so I'd say bear with us, bear with FEMA. There's still lessons to be learned. There's best practices. I do think it's going to be challenging in general to do a no rise within a 2D model, and I think there's some best practices to be learned, like using the same mesh for the existing conditions and proposed conditions, even though the terrain may be different, but to have the same mesh. Those are the kind of things that I think some best practices we can learn and help promote to better enable a no rise. So that's why I think, certainly stay tuned, stay in touch with us on the webinars. As we learn information, we learn best practices, we'll certainly help promote them.
Okay, I'm just going to go ahead and say it's 11:25 now. Our schedule, or it's 11:25 my time. Your mileage may vary. Our schedule is for this session to end at 11:30. Scott and Casey have agreed to hang around for a little while and answer questions until we run out, or somebody faints from hunger, or else Victoria kicks us all out of the room. I was asked to make a note that the lab tour for the Federal Highways Hydraulics Lab was, it was supposed to be yesterday, but we're still having technical difficulties, and that will be tomorrow at 12:45 Eastern time. Our next session today picks up at 2 o'clock Eastern time. So, all right, that said, I'm going to go back to quizzing our panelists here. Now, this one may start a fight. I know Scott likes to talk about this, but we have a couple of different questions about SRH2D versus RAS 2D. So
absolutely. Do you have a specific question, or you just want me to address it in general, Wes?
Well, one of them says which do you prefer, and one of them says which is better. So.
All right. Well, I can tackle that. We get this question all the time, and I would say, that the best model is the model that there are a couple things that you're most qualified to use, and that you fully understand on how to apply it for, I'm going to say specifically, detailed bridge hydraulics and scour analyses. I'd see, certainly Federal Highways has been working with reclamation since 2013. We've done a lot to invest in developing tools and best practices for detailed bridge hydraulics and scour. And many are familiar with the new scour tools we're developing. We're trying to make the DOT's job and others' jobs easiest to be able to do detailed bridge hydraulics and scour analyses. Now, that being said, it doesn't mean that HEC-RAS 2D can't be used, or other models, but there's certainly things that, like RAS 2D is certainly not set up well for now. It can't do pressure flow. I've seen about more than half a dozen ways to model piers in HEC-RAS 2D, and HEC is still a little quiet about this as far as what is the correct method. So it's important to understand the limitations of the model, and for that matter, if you are developing any model, you have to ask the question, and the state has to ask the question, who is qualified to review it? And so those are all key considerations. I have to be honest with you, I've seen a number of models, whether RAS 2D, SRH 2D, or others. If the user is not qualified in understanding the best way to apply it, the results are really questionable. So you have to understand that those that are teaching, say like RAS 2D, these days I've not seen a training session that's focused specifically on detailed bridge hydraulics. And so there's a lot of key points that are missed, namely mesh sensitivity and things that Casey alluded to that are very important. So whatever model you choose, just stay in touch, keep in touch with us at Federal Highways, and we'll provide best practices. So hopefully that kind of generally addresses that question, Wes.
I think you covered it pretty well. Yeah, it just depends on what you're qualified to do a lot. Let's see. The next question was related to Casey's case study. Was how did you determine your boundary values? Were they based on the old FEMA model that you started from?
Yeah. So for the development of the floodplain and the floodway model, we use the FEMA flows for the inflow flow boundary. And then for the downstream boundary, we used that BFE of 661 contour. And then that was, basically, that's what was utilized to verify that the 2D model water surface elevations at the effective BFEs and the effective cross sections were within that 0.5 feet criteria set forth by FEMA. I will say though, so even though it was one model, that's the procedure that was utilized for the FEMA aspects. There was another sensitivity analysis done on boundary conditions to make sure we were okay with the hydraulics through the bridge crossings that was used for the other analyses that we conducted, including the temporary wear platform, bridge scour, so on and so forth. So yeah, good question.
Okay, another one here. Have you had to do a no-rise evaluation for multiple storm events? And if so, was it successful?
I personally, for a no-rise FEMA protocol, have not had to do a utilizing any other flow other than the 1%.
Yeah, I've also not heard anybody having to do that either. Be interesting if somebody has experienced that.
Oh, don't say it's interesting, Scott. Now you're opening doors there, man.
Yeah, we're only talking FEMA criteria here. There's, who knows? There's all in different areas of the country. Obviously, there's different local agency requirements and communities. So,
okay, and a good general one here. Can you talk about limitations of 2D on culvert analysis?
So, well, the limitation in modeling culverts is currently for all culverts that we can't represent within the terrain. So, namely, anything but box culverts have to be represented by HY8, so which is based on HTS5 methodology. So, we're essentially inserting a 1D solution based on empirical equations into the 2D. That's currently the best practice. I certainly recommend where we can. If you can represent, if you've got a box culvert and it's on the main channel, so it's a main line structure, I certainly recommend modeling that box culvert as a pressure flow bridge rather than a HY8 1D structure. And as time goes, we certainly are looking into the, integrating circular conduits within the 2D domain, but that's probably a little farther out. So the best practice we have now is to be able to insert that 1D solution for 1D structures within the 2D solution.
Yeah, no, that's great. I would just add too, it's kind of similar to that question about, what model do you want to use? I think it really depends on the application and what ultimately you're trying to get out of this model. Because in the end, all these things are models. So just remember that.
Okay, and the next question is, how extensive is the bathymetry used for these 2D models? Do you sometimes use cross sections you would have for a 1D model and interpolate the bathymetry between them? And I had a very similar question to the effect of, is channel stamping acceptable for FEMA?
You want me to take that, Scott, or you want to?
But you give your 2 cents and I'll add to it.
Yeah. I know I might actually have a different opinion. I think one thing that I've noticed personally as a result of this implementation of utilizing two-dimensional models is kind of this separate issue in that having a very good understanding of survey techniques and what information is needed to develop a surface that's representative of the terrain. And so, to answer your question about can you use cross sections interpolated to create a section, my personal view on that would be if you're in a levied section with a prismatic channel, then yeah, it kind of like if you're a surveyor and you're out surveying and you think a typical section is representative of the ground and you're representing that in your surface, I'd say the same thing would be true for your 2D hydraulic model. But if you're in a condition where you're in a meandering system, or you have a lot of variation or hydraulic controls in your floodplain or channel, that would not be represented by having that typical section run through some stationing, then my suggestion would be that no, you wouldn't.
Yeah, I agree with that. I think the one thing it comes down to is I really perceive it, look at it from a PE perspective, is that if you're doing a work, you're willing to stamp it and say that to my best of my knowledge, this represents site conditions and water surface elevations. And so, you know, if you're asking a general question, can you stamp a channel throughout the entire reach with no surveyed sections? I would say no, that's not an acceptable approach. But if you have surveyed cross sections at a spacing, and you're simply stamping channels based on other information, that's totally acceptable. So there's probably not a black and white answer, but given that most states, it's becoming more and more common to have overbank LiDAR data, obviously then you just have to worry about having ample cross-section surveys. And it's certainly an acceptable practice to have detailed sections, surveyed sections through the bridge reach, and then maybe more widely spaced upstream and downstream. And then you can stamp in those areas to fill in the gaps. So again, I don't think FEMA's going to give specific guidance on whether you can stamp a channel or not. It comes down to really you as the PE being able to say, yes, this represents the terrain.
Yeah.
Definitely. No, go ahead, Casey.
No, go ahead, Wes.
I was just going to go ahead to say, I mean, similar to what you said earlier, I've definitely found myself spending a lot more time with our survey staff lately, you know, both in understanding how they do what they do and then discussing with them where we need our surveys done. Since we started doing a little more, you know, 2D modeling, it seems like it's become a lot more important. Although it did make me wonder, you know, what I was missing, you know, before we started doing this, but.
Yeah, no, early coordination with your survey team is instrumental. I mean, we were super fortunate to work with the WSDOT survey crew. They're some of the best in the business, in my opinion. Not only for collecting the data efficiently, but also collaborating, right? And so, you know, this case study is an example of that, where almost all of the topo data outside of the channel was utilized by existing LiDAR. And so rather than going and resurveying all that, all they would do is go in, take transects to verify that they were okay with the results of the LiDAR. And then similarly, you know, working with the Bureau to get their bathymetric data, we did something similar. That was taken a while ago, but instead of going and doing a full bathy topo, just took strategic locations to verify that the data was still good. And then so they were really able to focus their efforts on the vicinity of the bridge crossings. And so even though we had a 4-mile long reach over 2 miles wide, the actual amount of survey data conducted by the DOT wasn't that much. So yeah, you're right on, Wes. I mean, and Scott, as Scott alluded to, that coordination with your survey crew is essential. I highly recommend that hydraulic engineers go out with the survey crew at the scoping level to kind of get an idea and set what the domain and the limits that they need to get the right hydraulic model completed.
Okay, I want to drop back to some of the earlier questions now related to those two methodologies that Scott was talking about. So will one or both of these 2D floodway methodologies be included in the upcoming FEMA guidance?
Yeah, actually, both of those are referred to specifically in the FEMA guidance. But again, FEMA is not going to dictate which method to be used. And really those, what I presented is two methods that were primarily discussed. It really is going to be up to the local community and floodplain administrator to decide how they want to administrate that floodway. And so ultimately, whatever you use, you just have to verify or show to FEMA that you're not exceeding the allowable surcharge. I do think in the future, most communities will probably have a preference for more of the risk-based corridor, but others may be stuck on the, you know, oh, no, we only want to remove an equal amount on either side. That's really up to the community. But it's somewhat right now, you know, we're constrained to the current codified regulations and how that floodway is defined. In future potential changes to the CFRs, it may go to more of that risk-based approach rather than the surcharge, 1 foot surcharge in the floodway.
I don't know, this may complicate it, what I'm about to say, but I know, you know, we say this a lot, and it is very good advice to talk to your local community, but I know that we encounter a lot of rural communities that don't know, and that presents its own challenges, but, you know, that's just, there's not much you can do about that ahead of time.
I would say for those communities that don't know and don't have a preference, you would probably default to what I call the equal discharge reduction method that would be most consistent with what we've been, doing for years in the 1D model for equal conveyance reduction. That's probably if you want to say, the default or go-to method.
Okay. The next question, similar, was, are the BFE lines on 2-foot intervals per the FEMA guidance?
Yeah, as I noted, that I used 2-foot intervals mainly for presentation purposes, but there is, even reviewing the draft guidance, there's some specifications for spacing of BFE lines relative to map scale. And so I know there's been some more discussion and comments on that. So what actually comes out in the final guidance certainly may be different, but there will be some specifications on the contour interval to use. If you're at a really flat channel, you might find yourself having to use 0.2 foot contour intervals. So that will be dependent on the project.
So how does the equal discharge method handle changes in discharge like tributary inputs?
It's a great question. That does get challenging for the equal discharge reduction method. Tributary inputs could be treated as an internal boundary condition as far as an increase of flow. But if you did want to map the floodway up the main channel and the tributary, you would probably actually have to do those independently. Do one first and then do the other. But that's certainly, I mean, if you've done split flow analyses in 1D, it's challenging. It's going to be somewhat challenging in the 2D. But as far as just adding tributary inflows, we would probably best handle that as a internal boundary condition and just handle that inflow and map the floodway accordingly. Hopefully that answered the question.
All right. When averaging elevations along an evaluation line, do you also consider individual grids for elevations that exceed the surcharge limits?
Yes, if I understand that correctly. So we're looking at averages along the BFEs and to evaluate the average surcharge, but then FEMA will have an additional criteria that at any point, or if you want to look at it from a grid perspective, any point or grid values between those elevation or evaluation lines will have a greater tolerance, another ½ foot. So if your allowable surcharge is 1 foot rise at the evaluation lines, you'd have to ensure that all other point or grid values would not exceed that 1.5 foot total.
Okay. And the next question is, what is the reason for using discharge weighted average water surface elevations instead of purely using the average water surface elevation across the evaluation line?
Well, there's been much discussion on that at the PhD level, probably over my head. I think the consensus has been that the discharge weighted provides a better representation because simply if you have areas with really wide, shallow floodplains, it can be weighted such that you're not seeing the real change in the main channel. So I don't know if this one's absolutely critical. FEMA's we've gone back and forth on it, but we've kind of stuck with recommending the discharge weighted approach. But otherwise, I mean, you still could look at the linear approach. The important thing though is that you're averaging the values across the active water surface, that you wouldn't want to use the same linear averages based on the original line when you're looking at the floodway. So that's the only thing I would point out there.
Yeah, and just to add to that, I mean, Scott's point I think earlier was very important, is that ultimately what this is trying to do is provide a consistent methodology that is not as that's not subjective. So whether that's the location of your evaluation lines or the method used to get an average water surface elevation, I think one of the goals is just to do it in a consistent manner across the board. So yeah, just add that.
All right, we'll jump back down to some questions that came in during Casey's presentation. One model is great, but how would you handle a situation where the effective model is very old and regional discharges have increased significantly, or conversely, the FEMA model has discharges that are higher than what would be used by your agency and may be very conservative?
Okay, so no, those are all great points because that's probably what's going to happen, guaranteed, especially when you're dealing with some of these models that are from 1970s and 80s. Now, what I'll say to that is that even though the discharges and the topography from the effective model may be old, you're still going to be able to utilize one 2D model for the analysis. And that's really going to come from the development of your corrected effective model.
Well, yeah, in my experience on those, if you use different flows from what is currently effective, then you're looking at some kind of map revision for hydrology reasons. Independent of whatever hydraulic model you have.
Yeah, and that's where, once you get your core, I'll call it a core two-dimensional hydraulic model developed, you can really utilize that as a tool. No matter what 2D model you want to select, you can utilize that as a tool for doing all these different evaluations, not only for the different types of analyses, but for different flow conditions, different roughness code, all the different things that we're able to adjust within the 2D model for trying to verify what's actually happening on the ground.
Wes, let me just add in here. There's something that we're still working through. Is that currently, even if you're going from an existing 1D model to a 2D, the current FEMA regulations actually require, just because of the model change alone, would default you to having to do a CLOMAR. And so that's something that's still in discussion, that was even in the draft guidance, that maybe kind of could be a roadblock temporarily. It depends. In Casey's situation, they didn't have an effective model they could go back to, but still in many areas, that going from current effective to duplicate effective, if you're changing models, again, in itself currently requires a CLOMAR. So that's where we're hoping to maybe see some relaxing by FEMA, but those are things that we're still have to work through.
I know I've been told several times when the model was from the very old, or it wasn't available anymore, that we had to go back and recreate it, or either in the original format that it was, or if we were going to use a different model, we had to show similar results. That's a challenge.
What I've heard, our discussions lately have been, it's consistent with what Casey mentioned, is that your requirement will be to not necessarily rerun that model, but match the current effective BFEs within a half a foot. But again, that's based on discussions, and we'll have to see what the final guidance says.
Okay, this question sort of builds on that. It says, starting with HEC 2, which is still out there, and developing a duplicate effective model with SMS is like recreating a new model. Is there any advice that you guys have?
Well, I can tell you, if I understood that all correctly, I mean, you can, one thing that's pretty helpful is that you can export your cross sections from the 1D effective model and import those directly into SMS and compare your 2D results along those exact cross sections. So that can be helpful. But as far as criteria regarding the FEMA, again, we'll have to look to the specific guidance there. But there's plenty of tools available. It really comes down to what they require in the guidance.
I guess I'll add to that too, is, really think about, what you're trying to get out of the modeling. When some of these FEMA models were run back in, whether it's HEC 2 or prior to, that was done for flood insurance purposes, right? And so I hope that folks aren't utilizing FEMA models for assessing bridge scour, for example, because that's outside of what they originally were being developed for. And so that's where I think, the concept of the one hydraulic model with the 2D, if you're able to develop a corrected effective or existing conditions that can replicate the BFEs and the water surface elevations at the effective cross sections, then you can then use that 2D modeling tool to assess the change. But I guess I'll state the obvious, make sure that you are thinking about what the model was originally developed for and whether that should be applicable to the analysis that you're trying to do in present time.
Okay, here's another question that came in during Scott's presentation. Will there be any updates to entering a bridge into an SMS model? Modeling pressure flow as well as entering in pier information has been difficult in previous versions.
Most definitely. That's probably one of the areas we're working on the most, is trying to streamline that process. In fact, Aquaveo has a current task of automating mesh generation around bridges. I can tell you that Young Lai at Bureau of Reclamation has already improved the SRH2D code to accommodate complex 3D bridge geometry. And it's just a matter that will be introduced in SMS 13.2, which won't be too far away. So yeah, there are a lot of tools coming to improve the process and hopefully make it much easier. So we're trying. If you have any suggestions, please certainly contact me. And as you see what's available in 13.1, which will still be the same current version of SRH, but just some improved tools in SMS, please contact us. If you have ideas, many states are already doing that, suggested improvements, we welcome the input.
I believe some of those tools are going to be discussed in the next session, Scott, aren't they?
Yeah, in fact, Dr. Lai and Dr. Zundel are talking about some new features. Dr. Lai specifically in sediment transport, and Alan Zundel will be talking about new automated meshing techniques. And then I will highlight Jason Dayton from Nebraska DOT will be sharing his experience of actually doing scour analyses with both HEC-RAS 2D and SRH 2D. So.
Okay, let's see here. Can you clarify how you apply the elevation lines on the landscape with an addition of as islands as well?
So the evaluation lines, if I'm trying to understand that, if there are any islands that result, that you just treat the same, basically you connect the BFE lines so the averages reflect the entire width, if I'm understanding that correctly. So if you encroach on the floodway and there's still some apparent islands remaining because of the terrain, the averaged value is still only computed. This is another reason that the discharge weighting helps, that average value is only computed across where there's effective discharge, but it's still an average across that BFE contour. Did I get that, Wes?
I'm not entirely sure. Kate, if you're still there and you want to clarify that or add anything to it, send us a message and we'll readdress that. We have gotten some questions since the presentation ended, I think in response to the answers you guys have been giving. So we're whittling it down, but they're still coming in a little at a time. Okay, here's one for you. How does switching from open flow to bridge pressure flow complicate the 2D modeling?
I'm not, so I guess, so the question is, how does adding pressure flow complicate the 2D modeling? At least my understanding, if I understand the question correctly, it basically adds complex hydraulics through the bridge opening, especially if the deck is overtopping. And so what we found is that with pressure flow and with deck overtopping especially, that the mesh quality through the bridge opening is important. And so currently, using quadrilateral elements often offers the best solution, but still triangles are often still work. But so just when you have more complex hydraulics, sometimes the mesh needs more attention. So again, hopefully I got that one, Wes.
All right. Well, here's a good one that could start a fight. Do you think minimal rises due to energy gradient reduction and velocity reductions, which is a positive outcome, should be accepted as meeting the no rise criteria?
Should minimal velocity increase in middle water?
Should minimal elevation rises, which are caused by velocity reductions, still be considered a no rise?
Again, if I would say, in my opinion, yes, but again, it comes back to our insurable structures affected, and then does my opinion matter? I mean, it really comes down to what FEMA is going to agree as a no rise. And you know, if you can't meet that no rise, it kicks it into a CLOMAR. And I know if you had asked many folks from FEMA that's from their perspective is often not seen as a huge challenge. But I know from the state side it is. So I know most states avoid CLOMARs at all costs. So, I mean, this is a big deal. We'll continue to work on it. But I mean, anytime you see changes like that, I mean, it could be a showstopper for a no rise currently. So I would ask of all of you, if you have cases where you're running into this and you know it should be a no rise, but you're really wrestling on a case, you know, showing a slight rise, please share this example with us and we can bring that to FEMA and give it to it and say, hey, this is what states are dealing with. That would be very helpful to see and use as an example.
Yeah, I know I've had a few of those issues that I had with FEMA. I've taken to our regional hydraulics, you know, federal highways person and talked to her about it so that she has that, you know, to talk to FEMA during your periodic renegotiations with them, I guess.
All right,
Okay.
we're really going long here.
Yeah, do you guys need to go? Is anybody going to pass out from lack of food?
I think Victoria is telling us we should end here soon.
All right, it looks like 1 o'clock. So, all right,
Yeah.
we got a couple more minutes. Let me see if I have anything good here. Somebody here mentions direct connection between Open Bridge and SMS would probably be helpful. You know, I think that Open Bridge is a new Bentley product. You know, the Open Roads and Open Bridge. I assume that's what he's referring to there.
Right. That's a good point. I'm sorry.
No, you go ahead.
As you say, I'm not familiar with Open Bridge. I know there's been a lot of changes there. What we certainly will work towards is something fairly universal. You know, if you define the pier footprint and the bridge footprint, that SMS would be able to automatically generate a mesh from that. And so those kind of things would be easily exported from MicroStation or AutoCAD, whatever you're using.
Open Bridge and Open Road are the newer 3D versions of MicroStation. I know we're in the process of switching in Tennessee.
So one thing that we do need to look at, we've not looked at yet, is in SMS 13.1, most wouldn't know this yet, but there is a new 3D bridge feature. It's currently only there for presentation purposes, but will be used for scour and for pressure flow in the next version. Ultimately, and you know, this is something we can coordinate with Aquaveo to be able to export a 3D bridge from MicroStation or CAD and directly import it into SMS would be ideal. So that's something that we'll certainly look at.
All right, it looks like we had better wrap it up here. I know we have a few questions and comments left. We have all of your questions and contact information, and I'll see if I can guilt Scott and Casey into responding to those by email if you need responses there. So thank you everybody for hanging out as long as you have, and thank you to Scott and Casey for all your advice and, you know, experience here. We appreciate it. And, you know, if you found value in this session, make sure you come back at 2 o'clock in an hour for the next 2D session. So thank you, everybody.
Yes, thank you, everyone. We will resume in an hour. You'll just use the same link again to rejoin. I'm going to be ending this session for right now. Thank you.
Thanks all.